Okay, good afternoon to all. Welcome back. Today I'm going to discuss about segmentation. Last class we discussed about paging. So what means the segmentation? Segmentation is the memory management scheme that supports user view of memory. A logical address space is a collection of segments. Each segment has a name and a length, and the address specify both the segment name and offset within the segment. A program is a collection of segments, and segment is a logical unit such as main program, procedure, function, method, object, and so on. Common block, stack, symbol table, this one. Segmentation is the address specify both the segment name and the offset within the segment. The user therefore specify each address by two quantities such as segment name and an offset. This is the hardware of the segmentation. For simplicity of the implementation, segments are number and are referred to by a segment number and rather than by segment name. Logical address consists of two tuples, segment number and offset. Segment table maps two-dimensional physical address, and each table entry has base, contains the starting physical address and address where the segment resides in the memory. Limit is the specifies the length. This is the limit. Limit is the specifies the length of the segment. Segment table base register points to the segment table's location in memory. Segment table length register indicates number of segments used by program. And segment number is a legal if S is less than STLR. Segment table STLR, that is segment table length register. When the user program is compiled by the compiler, it constructs the segments. The loader takes all the segments and assigns the segment number. The mapping between the logical and physical address using the segmentation technique is known as the technique. Each entry in the segment table has limit and the base address. Here. So, the base address here contains the starting physical address of a segment where the limit address specifies the length of the segment. The logical address consists of two parts such as segment number and offset. The segment number is used as an index into the segment table. Consider the below example. Consider the example here. That means what is the segmentation? Next is what is the basic difference between the segmentation and paging? In segment paging system, the frame size is different right now, but in the segmentation case, frame and the segment whatever the it will the same size with the whatever. Here than the paging, there is a one is your physical memory, the frame, and another one is your there's a one side is the frame and another one is the page, right now. So frame size may be differ according to the page, but in case of the segmentation, both size are the same. Paging that means the frame size and also the segmentation size. Both should be the same. So that is the difference between the paging and the segmentation. Because paging, in case of the paging, though the frame size is differ than compared to the paging system. So what will happen when the data will be, suppose the size of the page is small compared to the frame, then again the fragmentation will occur. So to resolve that problem, the segmentation method is applied where both the page segmentation and the page size will be same, right? So the size fixed in segmentation table gives the total number of pages and therefore maximum page number in that segment with starting from 0. If the page table or page map table for a segment has entries for page 0 to 5, the address of the entry in the PMT for the desired page is a given segment S can be obtained, and by B plus P, that means base and the P is the value, where B can be obtained from the entry in the segmented table. So this is all about the paging and segmentation. So next come to the swapping method. What is the swapping generally? What is swapping? Swapping, a process can be swapped temporarily out of memory to a backing store, or what can do the swapping method, and then brought back into the memory for continued execution. So swapping is the method through which you can swap a process can be swapped temporarily out of memory to a backing store and then brought back into memory for continued execution. For example, assume a multiprogramming environment, suppose, with a round-robin CPU scheduling algorithm. When a quantum expires, the memory manager will start to swap out the process that just finished and to swap in another process to the memory space that has been freed, like in the round-robin method. So in the meantime, the CPU scheduler will allocate a time slice to some other process in memory. When each process finishes quantum, it will be swapped with another process, like the round-robin method. If there is a time slot is given, maybe time quantum is 1 millisecond, that means every process execute first for 1 millisecond. After that, if the job is not over, then it will be the preempted to, and other process is allowed to complete its 1 millisecond first. Then after that is the preemption method, and is also applied in the swapping concept. Ideally, the memory manager can swap process fast enough that some process will be in memory and ready to execute. When the processor scheduler wants to reschedule the CPU, the quantum must also be sufficiently large that reasonable amounts of computing are done between swaps. Next, what do in the rollout and roll-in? Swapping variant used for priority-based scheduling algorithm. If a higher priority process arrives and wants service, the memory manager can swap out the lower priority process so that it can load and execute. Lower priority process can be swapped back in and continue. This variant is sometimes called rollout and the roll-in. So normally a process that is swapped out will be swapped back into the same memory space and that is occupied previously. And this restriction is detected by the process cannot be moved to different location at its execution time. Next is in the swapping method, that means here it is the swap out and the swap again the swap in. That means this is the backing store. When the job is suppose it is required to swap out and other process allowed to enter this area, that means it is swap out from this main memory area to backing store, and again it is swap in another process P2 to this user space or the main memory area. So here backing, what is the backing store? Now fast disks large enough to accommodate copies of all memory images for all users. So this is today's class. Next class we are going to discuss. Thank you for all.